7-1 differential equations. If you're in the know, you can call them Dippy Q's. Yeah, equations. Okay? Just make yourself seem smart.
Did you say that just to sound like a nerd?
I don't think that makes you sound smart. If you just makes me sound like
It's for sure you sound like a nerd.
We're going to make Dippy Q's. All right, so I'm going to call them that just because it's quicker.
No.
So here we go. All right, what is a differential equation? It is an equation that contains a function and one or more derivatives. So here's your derivative. D by dx is your derivative. Y is your function. Okay? We got y prime is your derivative. We got y, 4x might be a function. What? Why not? One's a y prime. The differential equation. No. One's a y prime. That's a differential equation. Differential equation is an equation that contains a function and one or more derivatives. So there you go. Y double prime is your second derivative, y prime, and your function. Okay. So we're going to be looking at solutions. We're going to be looking at solutions. Now, when you always have a method for solving. We're not going to do that method today. We're just going to verify that, yes, indeed, that is a solution. Okay? This process will be sort of like when we did the identities in pre-cal, when you work from one thing and you replace with identities until you get to the end piece. Do you remember that? Okay. And we're going to be looking at eventually that there will be more than one solution because of that C that, remember, you kept having to add when you're doing that. Okay. So let's do a simple one. I'm not sure why that's dark blue down there, but anyway. All right, so we're going to verify. So let me switch it here. All right. Verify y equals 4 at e to the 4x is a solution. Okay, so this is your function, just to be clear. This is what? This is the key. Okay? All right, so this is what we have to verify. All right? dy, and remember we always started with the more complicated side, which is clearly that. We can't start with 0 and start making things up. Okay? But what we want to do, I don't know how long it's going to take us, but eventually we're going to get to 0. It may take us three steps. It may take us less than that. You get the process? Okay. All right. So in order to replace dy dx, we got to go up here and find dy dx. All right. So dy dx is the derivative of e to the 4x. How do we do that? E to the u. Good. Where, let me do this. Y equals e to the 4x. We're going to take the derivative. Y equals e to the u, where u is 4x. That's the chain rule. So y prime equals what? No. 4 e to the 4x. Because it's 4 e to the u. Let me do it in order here. Take the derivative of e to the u, which is e to the u. Derivative of 4x, which is 4. So 4, replace your u, that's your chain rule. Okay? So I'm going to replace that with right here. Okay? Minus 4. What am I going to replace the y with? E to the 4x, because that's what it is. And then there we go. It's clear that we're already to 0. So we don't need the other 2 steps. Okay, so some of these are real simple when you figure out the information. So the blue got replaced. Joey, start with the more complicated side and then get to the least complicated side. Okay,
you do the regular derivative of
dy dx is the regular derivative. Yes. All right. Any other questions? All right. Let's try another one. Verify that y equals radical 12 minus 4x squared is a solution of y prime plus 4x equals 0. Okay, so we're clearly going to start with y prime plus 4x equals 0. I'm going to show you another way that you might want to do it too. Instead of going this way, we can always go this way. The thing you can't do, though, is manipulate. You can't start moving around like this. Okay, don't do that because you're already assuming it's equal once you manipulate. Okay, so we just have to put in y prime. All right. Oh, we should have put in y too, shouldn't we? All right, let's try again here. What's y? Radical 12 minus 4x squared. Okay, and y prime. Okay, well, everybody take a minute and work it out.
Wait, you take the time of the radical 12 minus 4x squared.
This is y, then that's what y prime is, right? I'll give you a minute. Okay, work it through with me, Megan. Up.
Into the 1/2.
Okay,
So, not y prime.
where u equals.
12 minus 4x squared.
Okay,
So,
how about that?
I got 1/2 12 minus 4x squared. So then
Everybody, you didn't hit yourself.
yeah, I don't. Well.
Okay.
1/2
Times
negative
negative 8x. Okay. Simplify all that. What do we get?
4x over radical 12 minus 4x.
Okay. We're at my x. Use it in over here.
And isn't it 8?
Oh,
okay.
8 over 2 is 8. Okay.
should I leave it like that?
It doesn't matter. Does anybody have a preference for which way she should leave it? No, you don't want to pull it out if it's 2 to make 1.
Do 1 over.
Okay. That's a good idea. And you're going to do a radical probably?
Yeah.
Okay. You just want to be consistent with what you've already done. If you hadn't changed that to 1/2,
And you can put negative 4x for the 1.
okay, so there we go.
Yeah, why did you 14 side?
It's the same difference, isn't it?
Yeah, I guess.
This is, well, minus 4x squared to the 1/2, and then finally, whatever, rewrote it. I did it as a radical because I already had a radical. So you can fix this however you want to deal with it. All right, so now what? These are going to cancel. And what's my next obvious step?
Let's say 4x.
Negative 4x plus 4x, which equals 0. Okay? I told you I was going to show you a different way, and I didn't. I did it the same old way. Okay, so let me just show you how you can do it. A little different if you like this. Y prime plus 4x equals 0. 12 minus 4x squared, 4x over 12 minus 4x squared radical plus 4x equals 0. Negative 4x plus 4x equals 0. One more step. 0 equals 0. Where you don't touch the one side and eventually get the same thing to the other side. So you can do it like that if you like better. Same idea. Exactly the same. But some people get really weird. If they want to do it like this and I'm doing it like this, they get weird. But either way, either of those methods is the same thing, essentially. Okay? Any questions? Now, if you don't get this part right, this part's not going to work. So it is kind of a two-part thing. All right, let's try this. We've got a solution here, or a function. whatever you want to call it, same idea. And here's your differential equation. Okay, so where should I start, you think? dy dx or the 2y plus x? It's really half a dozen. What is the 6 for the other? Okay, you want to just try it?
Yeah.
All right, and now I'll do it both ways. I'll give you a minute. Just kidding. And we'll want to volunteer to do that side if you want to do it, but yeah, you can do it. You want to check. Yeah.
Negative x over 2.
That's negative 1/2 x.
It works. I can go back and not do it that way. I wasn't really thinking about it. I was just like,
Okay, so, okay, I'm not seeing the flow here. So this equals this equals this.
I just kept it in the same format. So it's like I replaced.
What did you replace from? So there's no,
Okay.
this, okay.
This right here. So this,
Start
I
with
did put
this. That
dydx.
should be it up here. And then I would go to here. Because then it's clear. And this is off to the side. Let's do this off to the side here. And then you can see that that's what you're plugging in, and that's what you're plugging in, and then, yeah. And then put that 30. As long as you're going here, I'm going away. Okay? Yeah. Yes. Or you can do it up here.
I mean, it's what you do.
Okay. All right, so let's see, well, Hannah works the other side again.
Do you have to show
Y plus x, 2, there's y plus x. She simplified this, became this, okay? She got some denominator. Then that became that, which became that, which is dy because she showed it right here.
Can you just say like dy dx equals negative 1/2? Like I did the entire thing and it equals 1/2, negative 1/2, and then I said dy dx equals.
Yeah, that's,
I just didn't write it out like that.
well, I mean, yeah, it's pretty clear. Okay, so now you're going to start with your, right now you just told me what dy dx is. Okay, all right. Now start with your verification, which means you have to start with, you're starting with this side, so what?
Yeah, I was replacing negative 1/2.
I know, but it's, we gotta have a flow here. Oh, okay, okay. Now do the rest. Yes.
So I did it.
Okay. You're showing that that
You're
equals
just finding the
that.
derivative of y.
Because if you put in, let's see, okay, you said, okay, so you should have this statement in front of this, 2y plus x equals, there's 2y plus
Yeah.
x equals dy dx. So that you literally have to write 2y plus x here, and then 2y plus x, just till you're done, equals, then that equals that, equals that, equals that, equals the end of dy.
Okay, that makes sense.
Yes. So then you don't need that. You're kind of mixing your things where you're saying, okay, am I doing this all the way down, and it equals that, or am I going from the beginning to the end? Okay, let's go. Dy dx equals, okay, this should not.
I just put this to separate.
Oh, I see. You're right. You're now. What you're going to there's that equals this.
Wait, is it like the same thing?
Yes. But you did that. And then you put
What did you get on
doesn't get nice. Okay.
That's on there.
All right.
Will you look at something? Like, I'm asking, instead of showing all my steps to find one from me, I'm gonna ask like John.
Yes. You should end with d by dx. Equals d by dx. Okay, bottom line here, people. Ladies, we need to be cognizant, ladies. We need to show that dy dx, here's Emma's dy dx, equals 2y plus x. There it is. Okay? Not so clear here, but if you do it like this, dy dx equals 2y plus x, clearly because negative 1/2 equals negative 1/2. Okay? So you've got to connect the dy dx to the 2y plus x. If you don't do that, you haven't verified. That's what verification is. Connecting dy dx to 2y plus x. Okay? All right, let's try solving. All right. Okay, ladies, here we go. Okay, so we're going in a little different route. We've done this before a little bit. Okay? We're going to solve. Kathleen. Hello. Focus. When solving differential equations, we are usually interested in finding a solution. Duh! That's what you're looking for when you're solving something. You're finding a solution, right? Okay. We're going to want a specific solution. Okay. These are your initial value problems because I have to give you an initial value. All right. So we'll put the steps here after we go here because I'm thinking you'll know how to do this. All right. Here we go. Find a solution of the differential equation y prime equals 3x plus 12. All right? We're looking for solution. What is the solution? Why do I hear talking? What is the solution? Otherwise known as the function, which is, in this case, y. Okay? So that's what we're looking for. All right. Now, how do we get from y prime to y? Yes. Okay. So that's the first step is once our y prime is isolated, which it usually is in this first section. That's why I'm writing this. Then we are going to, I went to use too many words, take the integrate both sides. Okay? We're going to integrate both sides. All right.
I'm starting to go a different route, and I keep going and see if it works.
That's what we're going to do.
But you're just ahead of us.
I just did it ahead of us. I think you're going to get there. Okay, ready? What's the antiderivative of y prime? Y. What's the antiderivative of 3x? Okay. What's the antiderivative of 12? And what do we have to remember, Claire? C. All right, there's our function. This is what we would call our general solution. Okay? So we have a lot of solutions that can fit that. They're all going to be parabolas, but they're going to go different routes. Okay? All right. We have a find the general solution. Use the initial given values. I'll just say given because it's not always initial. Given values to find the specific solution. Okay? That's a whole family of functions. We want to know which one goes through the ordered pair. What ordered pair am I referring to here? 2, 1. It's a weird look that you probably haven't seen much of, but that y of 2 means the x is 2. Usually we have the f of 2, but we're not calling it f of x. That's why they're changing it. Okay, so we are going to put x as 2, y as 1, and then the only thing left to find is c. Here we go. And we've done this a little bit, not a bunch, last chapter. 2 plus c. Okay? So 3 times 2 squared is what? Well, 12 over 2 is plus 24 plus c. What's 6 plus 24? So I'm going to subtract 30, so my c is negative 29. So now my specific solution is what?
Minus 20.
That's my specific solution. Okay.
So when it says just find the solution, are we assuming that it's specific?
Well, if they give you an ordered pair, it's specific. If they don't, it's a general. But usually they're pretty clear as far as find the general solution or find the specific solution that goes through whatever. Okay? So you're going to integrate. You're going to solve for y. There's some tricky log business that we got to talk about. These get a little weird, but I hope that seems a little familiar, does it? Okay, good. All right, any questions on that before we try another one? All right, let's do this one. What? Oh, okay. All right, for what values of r, I'm going to get rid of this, does the function y equals e to the rx x satisfy? So r in this case is your constant. All right, so we have to figure out, this is a little different because of that y double prime. We don't really, it's a little bit different to solve because it's not really saying solve. Anybody have an idea of what we could do? Emma?
Should we solve the y prime?
I think that's a great idea. Okay, if y prime is, if y is e to the rx, how do we find y prime? E to the u, good work. All right, r is just some goofy constant, so what's y prime?
Or e to the rx.
R e to the rx, okay? So how about we put that in here and see what happens? R e to the rx. All right, we need to find double prime. You're on it, Miss Emma. All right. So that means we got to find the derivative of that. R is a constant. So that's R e to the u again, right? Where u equals rx. Okay. So R is a constant. Just hang around. What's the derivative of u? E to the U again times what's the derivative of Rx? Not X, right hand? All right, so what's that? R squared. So there's a 2, there's an R squared, and there's e to the Rx. Minus e to the Rx, because y is right here. Equals 0. We're going to solve this for R. It's not that rough. It looks weird because you got a lot of weird things going on.
Two numbers.
Mm-hmm. Calculus at its finest. You don't use the numbers. Okay, what can we do to make that a little easier? Factor out what? E to the Rx. Nice. Okay, so what's left?
2R squared minus
Where you get 9?
I said nothing.
Oh, okay, sorry. All right. Okay, now what? Can we factor this anymore? I believe we can. 2R and R. Minus 1 plus 1. Good, Emily. That would give you plus 2R here, minus 1R to give us plus 1R. Okay, now, when we got 0, we got a bunch of factors. What do we know about each of those factors? It could be 0. Okay, this is easy. R equals 1/2, that's one value. R equals -1, that's another. What about that one? E to the Rx. Do you remember what e to the any power either looks like this, or depending on if r would be a fraction, would look like this? Does that cross over and give you 0? So there's no answer there. So your answer is, for what values of r? 1/2 and -1. They didn't ask, but what are your solutions to that divvy cube? Y equals
e to the -1 or to the -x.
Okay, and
Y equals e to the 1/2 or x over 2.
yes, either way. Okay. So there's so many different approaches. Be careful about just like most of you have decided memorizing in calculus is not a great idea for everything. Yes, you have to memorize some theory and all that, but I haven't really seen you all learning like that this year. Like, kind of got away from that, which is good. Okay. So just if they ask for the solutions, I mean, they gave you the general solution basically. This was a general solution. They just didn't call it that. And so you had to figure out the solutions. Okay. All right, let's try this one. This is more like the first one we did. Find a solution of the differential equation that satisfies the initial condition y of 0 equals 2. Do you want to try it by yourself? Are you ready? All right, ladies. Here we go. That's equal to y. It didn't look familiar to me. Okay. What y'all doing? What'd you do first? Okay. You mean integrate?
Whatever, yeah. I just didn't.
Whatever, they're opposites, so.
Take the integer.
Okay, all right. Okay. So this is y. All right.
Pull the constant with that.
Sure, that's a great idea.
I just read this first. Would that be okay if you distribute it first? And then
Yes.
Did the integer
It won't matter. Well, we can do that.
No, it's okay. I just wanted to clarify. You're good.
Right? Okay. What is the antiderivative of x squared minus 1? That those of you that pulled out the 1/2. Hannah?
X to the third over 3 minus x close bracket plus c.
Okay, and you can put the c in, but half the c is still a constant, so it's all good. All right. And then I'll do it with the distributed here in a minute. So what's that? 1/6 x cubed minus 1/2 x plus c equals y. That's my, what do you call this? General solution. Okay? All right, and now I'm going to plug in 0, 2. Right? Looking good. 0 minus 0 plus c equals 2. So what's my specific solution? Know what you had, Hannah? All right. Now, if you distributed first, you'll get 1/2 x cubed over 3. There's your 1/6 minus 1/2 x plus c. Then you put it in 0 and 2. You get the same thing. It's the same thing. So it doesn't matter. Okay? Any questions? All right. The next one's kind of, it's harder. Okay? Now, because it's got some log business in it. All right. Find the solution of 1/10 minus 2y dy equals -1/x dx.
No.
You can try it. Let's try the first step and then stop. First step is antiderivative and then stop. All right. We should be able to do that. Do a lot harder than that on the test, that's for sure. What? Okay, you gotta do, you're doing your substitution through the whole process, don't start in the middle of it. Why do you start in the middle?
Why are we taking the antiderivative when it's regular y? Because of the dy dx?
Yeah, this says that's a dy, so you gotta find the antiderivative to find y.
Okay.
Okay. Anybody done with that left side antiderivative? Yes? What do you have, Kat?
Do I plug the u back in?
Yeah, give me the whole thing and then I'll see if it's right, because I haven't done any. Are you giving me the final step of the antiderivative? Just give me the without the integral.
Maybe 1/2
Okay, that's not the final.
ln of 10 minus 2y.
Perfect. Okay. Did y'all get that? Good. So you had to do this. Now, the people that did the U substitution that tried to stop in the middle and do this, it's not usually a good idea. Okay, we got to work through the process. I have -1/2 du that equals dy, and then I have 1/u. Okay, and then ln of u, and then substitute. Okay, good job, Kat. Okay, so here we go. The other side's easier, right? What's the other side look like? Negative ln of x Are you sure about that? Is there something missing there? Plus C. Okay, don't forget your absolute value. I haven't heard.
Yeah, do we put it on the other side too?
Do we?
Yeah.
Well, then C minus C would cancel out. No. We're going to put, I was waiting for somebody to ask about that because we've done the last 3 examples. No one asked. Okay, the C gets on the side. We don't want them to cancel out each other because then we have no C, right? C gets on the side of the dependent variable. So I like to say it's going to be X side, but it's not always going to be X.
Maybe not.
But if it's dy dx, this is the independent variable.
Would you not want to change?
No, the dependent.
Would you not want to change?
Dependent, right.
To,
What did I say? Independent? Yeah, right. Dependent. Thank you, Em.
would you not want to change this to ln of 10x 10 minus 2 to ln of 10x minus 2?
What? To what?
Because when it's like 2 ln's that are added together, it's the
But we have a plus C there that's going to foul that whole thing up. She's trying to put some things together. Remember, our next step is to solve for y. So, solving for y when y is inside here. What do you want to do first? Okay. So that's really multiplying by -2. Okay. Does that sound good, everybody? All right. Now, if it was ln of blah, blah, blah equals ln of blah, 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 yeah, we could just totally subtract, get rid of the ln's and we're done. But with that C, we can't do that. We have to do it what way? Who knows what to do next? Yes? We have to change it to exponential. These are both E's.
So e to the 10 minus
E to the 2 ln x plus C equals 10 minus 2y. You are going from ln of x equals y, e to the y equals x. That's your basic logarithm exponential. E to the y equals x. That's what we're doing, and that's what you're going to have to do.
Where did the other ln go?
Right here. And then that one went here. That went to exponential power property. Yes.
So they need to be in absolute values, the 10 minus 2y.
Does it?
Yes.
Is e to any power positive? Didn't we just talk about e to any power looks like this or like this? Okay, so we can drop the absolute value over on that one side. Okay. Still solving for y, people. Now what? Minus 10, okay. We're going to clean this side up here in a minute. And divide by -2. It's really ugly. Okay. Did we lose anybody there? We're going to clean this up. If e to the ln of blah, blah, blah gives us, those cancel, we get the blah, 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 right? Okay, so let's try to figure out where this 2 could go so that e and ln would be next to each other. First, understand that this little guy here is, before we get too crazy here, that. You agree? Okay. So I'm going to make this, and I didn't decide this, but we're going to make that K, another name for a different constant. Okay, so here we go. E to the 2 ln x times K. I'm going to go ahead and put the K out front then. K is e to the c. You won't have to remember that K is e to the c, but you'll have to know where you got that. Minus 10 over -2 is finally our general solution. Well, actually, we could even go any further than that. Dang it. Okay. Remember, we were going to try and simplify this. Okay. -2 minus 10. We had e to the ln of something. Remember, those would cancel. So what can we do with that 2? It is already out front. As an exponent. This would, hold up. Okay, so the factor is an exponent. That's your log rules, people. Read Cal, chapter 4.
Oh, that makes sense.
Okay, how'd I get what, Hannah?
Never mind.
Okay, now x squared. Is x squared always going to be positive?
Yes.
Then we can now get rid of those epsilon value bars. Okay?
It's like pretty easy before this.
Yeah. Some of it, yep. Okay, now we got E and ln. Tell me what my final general solution is. Okay, x squared minus 10 all over -2. Sounds good to me.
I don't understand
What
the
if
K.
you just change
That's a property.
I just don't understand why you use 10.
It's just a lot.
It just makes it easier if there's a constant outside of your thing.
Yeah,
But
you
it's,
can see back in.
no. Okay, now we're looking at 2. No, that's the general solution.
That is horrifying.
That would be like if you
E to the ln base E of 2. What is that? It's 2 because this is exponential power. I'm going to put it in log power. ln, my base is E. This is my exponent because that's my logarithm. The only thing this could be is 2. In order for this to be equal to this, we got to have a 2 there, right? So that's why that answer is 2. These cancel each other out, basically, if you want to just remember it. Okay? You didn't know this. You would put a x in here. And then if you look at it, it's really a duh. But again, this is exponential form, log form. You've got to be able to switch back and forth. Okay? All right, 2, 2. Let's plug it in. 2, 2, and find our k. And no, I know some of y'all asked, you won't have to go back to e to the c power per k. That's what I did. Okay, so 2 equals k, 2 squared minus 10 all over -2. Solve for k. I know what I'm going to do first. I'm going to multiply this -10.
It's a good 2 on the
Oh,
bottom.
sorry. Well, thank you. That would have been bad. I got -4. 4k minus 10. Back to algebra 1 here, right? Just took us 25 steps to get there. What's k?
-3.
You did not. What?
I said Ellen.
Okay. So what's our specific solution? Y equals, we're back to our general. That's why I always circle it, because then it's like, oh, here it is. 3/2 x squared minus 10 all over -2. That's ugly, isn't it? Let's multiply by 2 and get rid of the complex and then be done with it. 3x squared minus 20 all over -4. Because there's a complex piece. All right, that's crazy.
Yeah, can we breathe for like 1 second?
I didn't know you weren't breathing. Certainly breathe. Certainly.